All right, let's talk about this one. So as I go in to do the transformations, I need to know what my A, my H, and my K are. So I'm going to write transformation form, vertex form, up here. I will give this form to you on the test. So you'll have that as reference. But you always want to look back at that as you're identifying your A, your H, and your K. What are my A, H, and K? Pick one of them out and tell me what value it is. 4 is my A value. Absolutely correct. H is -2. Nice work. Right here, we see the opposite of H. So that means H is actually -2. And -3 is our K value. Yes. So what will that K value of -3 do to my graph? Which way is this one going? Yep, this one's going down 3. So for my transformations, remember, transformations, I want words. And FYI, when we get time for the test, I do want you guys to write this out in words. Don't just give me arrows. Write down or up or left or right. Left 2, that's what my H value is doing to it. And what about the A value? Vertically stretched, yes. What kind of number would I be looking at if it was a compression? A decimal or a fraction for a compression. Any numbers that are farther away from 0 than 1, whether it's positive or negative, if it's bigger than 1, it's going to be a stretch. So this is vertically stretched by 4. Does it reflect over the x-axis at all? Correct. If our A is a negative number, that's what would make it point down, open down. This one is not a negative A. Our vertex is the ordered pair, HK. Absolutely correct. -2, -3. The axis of symmetry is always an equation of a line, and it's always going to be x equals h. X equals -2. It has to cut through my vertex and through the x-axis. Vertical line. That's why it's the x equals, because we have to go through the x-axis. And so then I write down that it's the x part of my vertex. For general form, this is the first feature now, or the first thing we've been asked to do, that you can't just look at the equation and get it. We need to follow order of operations. So first, we're going to do exponents. I know that in order of operations, parentheses comes first. Yep, we have x plus 2, and there's nothing more I can do to that to simplify it. So I'm looking at the fact that it is x plus 2 squared. What does it mean for something to be squared? We're going to multiply it by itself. So that's the first thing I'm going to do here. X plus 2 times another x plus 2. We need to use double distribution. Remember, when we're squaring a binomial like this, you can't just square the x and square the 2. That is not how this works. So I'm going to take the x and distribute it to both pieces. So I'd get x squared plus 2x. And then I take the 2 and I distribute that to both pieces. Plus 2x plus 4. Are there any like terms that we can combine together? The 2x and 2x. So I end up with x squared plus 4x plus 4. That was just what I got from doing the exponents part. Now, we're going to distribute our a value. Originally, this was y equals 4, and then we had our binomial that was squared, but we've just figured out what that is. I got x squared plus 4x plus 4. And then we have that minus 3 on the end. There's only one number that I'm not going to distribute the 4 to. Which number am I not going to distribute to? The negative 3. Absolutely correct. So we're going to take that 4 and we're going to distribute it to everybody. So I have y equals 4x squared plus 16x plus 16. This minus 3 comes down. Very last thing I have to do is combine my like terms. Mm-hmm. So I've got 16 minus 3. What is 16 minus 3? 13. Y equals 4x squared plus 16x plus 13 is my general form. One of those numbers is my y-intercept.
Your last number.
Last number, the 13 on the end, is my y-intercept. When I go to write this, though, I want to write a full ordered pair. Where does the 13 go in my ordered pair? Second number. And what will the first number always be if it's a y-intercept? 0. Because if we're on the y-axis, that means I didn't go left or right at all, but I did go up or down. Do you guys have any questions about number 1 at all? We'll keep practicing with our forms today too. Number 2, like I said, number 2 is review from Algebra 1. First thing I notice about this one when I look at it is this c to the power of 0. Anything to the power of 0 is the same as what? 1. It's not the same as c to the first power. It's just the same as the number 1. So I can just replace it with a number 1 here. What is negative 3 times 1? Yep, negative 3. So when I replace that with a positive 1, it's almost like it just cancels out of my expression. Next thing I notice about this is this b right here with a negative exponent on it. I can't have negative exponents and it still be fully simplified. So how do I get rid of, or how do I change that exponent from being a negative to being a positive? Switch the sides, yes. It's going to go down into my denominator. So up on top I would have negative 3 and a. Down on the bottom I have 9a b squared. But then b to the first power moves to the bottom. We can combine those b's together. This would be b to what power when I combine it? Yep, b to the third power. Notice I still haven't done anything with that squared on the outside. We're not going to touch that until the very end. We're simplifying inside the parentheses first. I see 2 things inside these parentheses that will still simplify. Yep. What will happen with the a's? The a's are going to cancel out. Absolutely correct. I'm going to bring this up here. So I have negative 3 in my numerator. I have 9b cubed in my denominator. What can I do with negative 3 and negative 9? Divide them by 3. 3 is the biggest thing that goes into both of those. So what would I have in my numerator then? Negative 1. What would I have in my denominator? 3 and b cubed. All right, I think the inside is as simplified as we can get it. What does it mean for something to be squared? Multiply it by itself. So I have negative 1, 3b cubed times another negative 1 over 3b cubed. When we multiply fractions together, we multiply numerator to numerator and denominator to denominator, straight across. What is negative 1 times negative 1? Positive 1. And then I multiply my coefficients, 3 times 3, 9. B to the third times another b to the third. B to the 6th. So here's what's going on there. Let me make this just a little bit smaller so that I can write it out. The exponent means how many times you're multiplying something by itself, right? So when I see b to the third, that means b times b times b. But then we said we were multiplying this here, and here I have another b to the third, so b times b times b. So how many times are we multiplying b by itself? 6 times. That's why that is my exponent. Doing good on the bell work? All right, page 75 for me, please. Page 75. We're going to be looking at some tables today, and we're going to figure out how to write the equations of parabolas from tables. When I'm looking at a table, the first thing I need to know is whether or not it's quadratic. If there are constant second differences in the y values, constant second differences in the y values means we are looking at something that is quadratic. Once we know a table is quadratic, we can find the vertex on that table by looking for where the y values start to repeat themselves.
So once you see it going like, you repeatedly see like the number 2, you know what that is?
Not necessarily. We'll look at a table here in just a minute, and I'll show you exactly what I mean when I say this. The y values begin to repeat on either side of the vertex. Y values begin to repeat on either side of our vertex here. Another way of thinking about this is that the y values change direction. So when I'm looking at my y values, what I mean by that is I'm looking just at the y column, and I see the numbers are getting bigger, getting bigger, getting bigger, and then they start to get smaller, where it makes that change. Or they're getting smaller, getting smaller, getting smaller, and then they start to get bigger. I would know that that's where the parabola has changed around there. So I've found the bottom point or the top point. All right, let's look at this table here. What is this table showing me? It's going by 2's at the top, yep. Yep. We've got our input and our output. What is my x variable representing here? Time in the air. And my y variable? Height of the drive. Why do you think this table doesn't have any negative x values on it?
It
Keeps going up? But why didn't it start at a negative number? What are the x values again? What are the x values representing? The time. So why do we not have any negatives there? We don't have negative time. Tell me about the y values. Why are there no negatives there? Yeah, our height isn't going to be negative either. In this case, where we're talking about a golf ball, to have a negative height means that it's going to bury itself into the ground and keep going all the way through the earth. First thing I need to know about this table is whether or not it's quadratic. So I'm looking for my constant second differences. To go from 0 to 80, did things get bigger or smaller? Bigger. By how much? 80. To go from 80 to 128, did it get bigger or smaller? Bigger. By 48 this time. To go from 128 to 144, did we get bigger or smaller? Bigger. By, what is that, 16, I think? From 144 to 128, did we get bigger again?
No,
We got smaller. Do you remember how I said up above that it's going to change direction? Up until this point, we were getting bigger, bigger, bigger. Now it's starting to get smaller. That should be where it starts to curve. From 128 to 80, we're getting smaller by 48. And from 80 to 0, we got smaller by 80. All of those numbers are different. If those numbers were all the same, then this would be the table for a line. To check my second differences, I'm seeing what the change is between these values here. To go from 80 to 48, are you getting bigger or smaller? Smaller. Smaller by how much? 80 minus what would give you 48? 32. From 48 to 16, we're getting smaller again. Yep, smaller by 32 from positive 16 to negative 16. Those are a distance of 32 units apart on the number line, and it's getting smaller, so we'd say minus. From negative 16 to negative 48, that gets smaller by 32. And from negative 48 to negative 80, that gets smaller by 32. That's how I know this is quadratic. Yep, the second differences are an equal distance apart. Yep. Do you guys remember when I pointed out on this table where it stopped getting bigger and bigger and it started getting smaller and smaller? Where did that change happen? So that's 6 and 144 right here. On either side of it, the y values are exactly the same, right? This is the tipping point where it changed directions. This is my vertex. The y value of 128 repeated on either side. Y values went from getting bigger and bigger and bigger to all of a sudden smaller and smaller and smaller. We have our vertex, so we have HK. They want me to write vertex form. That's y equals a times x minus h squared plus k. I have almost everything I need for that. What piece do I still need? First one, we need our a value. We're going to have to find that one. But I can substitute in what I've already got. What would I see if I substituted in the h and the k values? Yep, so we're going to see x minus 6 and then squared. And what would be on the outside?
144.
Yep, plus 144. So I know my vertex form is going to look a lot like that. I just need to figure out what that A value is. That means I'm going to have to substitute things in for X and for Y so that I have A as the only unknown thing here. Because math is really good at finding stuff, but only one thing at a time. I have a whole table full of X and Y pairs that are on this parabola. I need to pick out any one of those XY pairs and substitute it in here for X and for Y, and then we'll work backwards to find what A is. You can pick any pair off the table you want, except the vertex, because we've already used those numbers. What ordered pair do you guys want to use? Doesn't matter which one you pick, as long as it's not the vertex. Which one? 2 and 80. Perfect. So we will use this to find A. We're going to put the 2 in the place of what? Should it go in for the X or for the Y? X. So we're going to put 2 in the place of X. So I have 2 minus 6 inside here. I have my plus 144 here. We have our A here. So what am I putting in the place of Y? That's where the 80 goes. So the X right here and the Y right here. Remember, it doesn't matter which ordered pair you pick off the table. I need to use order of operations now to get A all by itself. What should I do first according to order of operations? Parentheses. What is 2 minus 6? Negative 4. And then we want to do what to that? What would my next thing be? We did parentheses, then you do exponents. What is negative 4 squared? Positive 16. So I have 80 equals A. That's being multiplied to a positive 16 plus 144. I normally would write this right here as 16A. Subtract 144 from both sides. What is 80 minus 144? Yep, 80 minus 144. Grab a calculator if you need to, guys. Negative. Negative what? Negative 64. The last thing I need to do to figure out what that A value is, we're going to divide both sides by 16. So do negative 64 divided by 16, and tell me what you get. Negative 4. So this is what I'm going to use for my A value. It's going to go in right here for A, and all the rest of this is going to look exactly the same with my vertex, my H and K in there. So I would have Y equals negative 4 times X minus 6 squared plus 144.
So vertically compress those on the graph.
This is actually going to be a vertical stretch. The negative just took it and flipped it upside down. Remember, it's only going to be a compression if the number, whether it's positive or negative, is smaller than 1. This A value we're going to use in our other two forms as well. We have to find it, but you don't have to find it each time. It's going to be the same A value for my other forms. Question D asks me to find what on the table? Zeros. What's a synonym for zeros? What's a synonym for zeros? The x intercepts the roots. What do I look for on the table if I'm finding the x-intercepts? But I want my zeros. That would be represented by what? If it's my x-intercepts, what would that mean? Let me draw a real quick sketch here. We already know that it's going to be upside down. When it crosses the x-axis. So how can I find that on a table? What would I be looking for? Not just where it starts to go down. How would I know on the table if it's an x-intercept? Where it crosses the x-axis. What has to be true about these ordered pairs? No, not necessarily. They could be. There's one number that will be the same in both of these ordered pairs. 0. In which spot, the x or the y? The y, because you don't go up or down at all. We move left and right, but you don't go up or down at all if you're going to stay on the x-axis. So explain how you found them. You're going to look for where the y value is 0. Do you guys see that on the table anywhere? Yep, we've got one right here. So here's a root. And then we've got another one right over here. So this would also be a root. The x parts of those ordered pairs, x is 0 and x is 12. We've written these as ordered pairs. I want you guys to be able to go back and forth between writing them as ordered pairs or writing them as x equals. They want me to write factored form down here. We already know our a value is -4, right? To write factored form, it's y equals a, and then x minus root 1, x minus root 2. So I've got my two roots. Factors, if you remember, always have to be equal to 0. Yep, so like this one right here, x, this is a factor because it's already equal to 0. So I can just write that down here. Most of the time our factors are going to be inside parentheses. For x equals 12, that's not equal to 0 yet. What do I need to do to it to get it equal to 0? Yep, we're going to subtract 12 from both sides. So I have x minus 12 equals 0. Once it's equal to 0, the other side of the equal sign is my factor. So I would have x minus 12. General form, that's our ABC form. ax squared plus bx plus c. Remember, general form does not have any parentheses in it at all. What could you do right here if I wanted you to simplify that so that it got written without any parentheses at all? Distribute. That's exactly what we're going to do. Negative 4x is going to get distributed to x minus 12. I only need to do single distribution because this is not parentheses here. If there was parentheses there, I would need to do double distribution. So I have negative 4x squared. I have a positive 48x. So y equals negative 4x squared plus 48x. Where's my y-intercept on this? There isn't one. So what would the ordered pair be for that? Because it does have a value. 0. C is 0, so the y-intercept would be 0, 0. I'm going to write that down because that's going to help me sketch my graph down here. This graph at the bottom is not an AHK graph. We're not going to be super precise. I just want a big idea of what this looks like. So there's a couple things that we've identified already about this graph that's going to help me get a sketch down. Yes, ma'am. -4. Hold on. There we go, right here. Yep. Once you find that a value, you're going to use the same a value all throughout. Good question. All right, we found our y-intercept. We said that was at 0, 0. Yep. We know our roots are at 0 and at 12, right? And do we know the vertex?
Yes.
What is our vertex?
It is 6
Yep, 6 and 144. So I've got these 4 points that I can graph. 0, 0, right here. That's both an x-intercept and a y-intercept here. 12, somewhere over here. I know that 6 is going to be halfway in between 0 and 12. It goes up to 144. So I'm going to have a point somewhere here. That's my vertex. And then I can just sketch in. I know it's going to be pointing down because it has that negative a value. And this one wouldn't have arrows on the ends of it because remember, this is representing a golf ball. And if I put arrows on the ends of it, it's going to bury itself into the ground and keep on going like a drill right through the earth. All right. Turn to page 46 for me. I want to look at one more table. We're going to start just by identifying our big pieces. And if we have time, we'll write an equation. Look at this table for me. What'd you say? Oh, okay, sorry. Page 76. Where is our vertex? 310. How did you know that it was 310?
Because that's the only number that's not repeated.
Yeah. On either side of this 10, notice my y values repeat right there. My y values repeat on either side. All right. Do I know what my a value is here? I'm going to have to find it, just like we did before. We do know our h and k, though, don't we? So I can substitute those in, y equals a, and then I would have x minus 3 squared plus 10. We can pick any point we want to off this table to help us figure out what our a is. Are you guys okay if we go with 8 and 0? I would just rather not deal with decimals if I don't have to, and we can't use 310 because we've already used those numbers. So I'm going to use this to find a. So this is what I'm going to put in for x, and this is what I'm going to put in for y. So I have 0 equals a, and then in here I have 8 minus 3. What is 8 minus 3? 5. And then I'm going to take the 5 and square it. What is 5 squared? 25. So I have 0 equals 25a plus 10. I want to get the a all alone. What can I do to both sides? Subtract. What am I subtracting? 10. Subtract 10 from both sides. So I have negative 10 equals 25a. To get the a all alone? What'd you say? Not subtract. Divide. I want to get the a alone, and right now it has a 25 next to it. Those are being multiplied, so I'm going to divide both sides by 25. Grab your calculators for me. Yeah, there you go. Negative 0.4 is my a value. So once I've got that, I can take this right here, and I'm going to recopy that, but with that a value in place. So there's my vertex form. And negative 0.4 is my a value for all the other forms. Part D asks me to find what? Find the zeros, the roots, the x-intercepts. What am I looking for on the table again? Yeah. There is only one. However, I know that the only way there's only one root is if the vertex is the x-intercept. Here's where my y value is 0, right? So that's a root. But you guys told me that this was the vertex. Are they the same? So I've got to go find the other one. But look at the pattern on this table. We've got our vertex of 310 here. On either side of this, my y values repeat. 9.6, 9.6. 8.4, 8.4. 6.4, 6.4. 3.6, so if I jumped backwards on the table here, what would the y value be? I'd have negative 1 up here, because that would jump backwards. What would the output be, the y value? Not a negative, it's just going to repeat. So it's going to be a 3.6. Is that a root? No. So I'm going to jump backwards again. Negative 2. What would the y value be there? 0. There's my other root. Had to work backwards on the table. So my factored form, we know our a value from before is negative 0.4. I would have x minus 8 and x plus 2, because remember I have to get these equal to 0 to find my factors. Homework number 5 is due tomorrow. You guys are going to practice with these tables. I will see you guys then. Please let me know if you have any questions.